Good morning, everyone. 4D scene reconstruction and reconstruction of complex dynamic scenes in 3D points over time for various objects in this wide baseline and captured using static or no knowledge of background, structure, or segment. Challenging indoor and outdoor scenes with a like background, structure, or segment. Case here, if we initialize the method with the scene. Apart from this, the parent. We have uncalibrated, modified, and reconstructed temporal construction. All the elements are final 4D scene reconstruction and segmentation of. So let's start with our framework. The length of the sequence. Feature between pair of views. The feature matches are then used. The sparse scene reconstruction is clustered in once you have the and that is refined using an optimization framework. First frame of the sequence only. Time instance, we assume the dynamic parts of the scene are reconstructed. Furthermore, temporal now let's start with the feature detection and matching is performed between pair of views. Reconstruction is clustered in 3D and the image in different objects in the scene. For each shown on the right hand side again. The initial course reconstruction. All the points. Delineate triangulation is performed in one view and is propagated. The delineate triangulation is propagated in 3D to object in the scene for the first frame only. The initial course reconstruction needs refinement to obtain the. We create a proxy for the background using the bounding box. The objects on the right hand side for the first frame. Dynamic features in the scene and reconstruct only the dynamic. So we have two frames and all the views. We match the 2D are prone to errors because of occlusion and camera. The net motion is identified and median filtering is applied to identify the dynamic features. Sparse point-to-point temporal correspondence Once we have this, the mesh from the previous frame on the projected mask. The optical flow vectors are combined with the correspondences shown here. Obtain the initial coarse reconstruction for the dynamic object. Mesh shown on the right hand side. Coherence for jugular dataset. This dataset is captured and on the right is the depth, and the color is propagated throughout the entire sequence. So the object remains constant over time. As explained before, we are reconstruction for the first frame, and for the Guillemot et al. Proposed a joint refinement and we use this concept in our framework, and we formulate the computation of depth at each point, where L is the label and D is the depth. Information to refine the depth. Labels to vary smoothly within each layer. Out is shown on the left hand side. As you can see, there is smoothness term in the minimization framework. Obtained from the initial segmentation of background and foreground with contrast information is combined with interactive 2D segmentation framework to obtain star convexity ensured that all, but the star convexity constraint Wilson et al. Proposed geodesic star to a star center through geodesic distances. So the object can be improved by introducing in combination with it. So as a interactive with manual interaction, but we have automated it. Our centers to initialize the geodesic star convexity. As you can see, the reconstructed model is much more. These are some segmentation results. The constraint with multiple star centers. Now, as I explained before, here is one of the results. So we have input coherence, and as you can see, the results are much better than without temporal coherence, and we can see the same using temporal coherence in the framework. Follow-up methods. Furukawa, Guillemot, and is a generic reconstruction method and it's state-of-the-art. Provides per-frame reconstruction of the scene, but Guillemot is a joint reconstruction and refinement approach which requires background and initial segmentation of the scene. Approach which does not need any priors. The proposed approach requires no method satisfying all the three constraints. Compared against Guillemot and Mustafa, captured with only static canvas, and magician in both the cases, the segmentation obtained using these are the three methods using the same initial course reconstruction. As you can see, the reconstructed models reconstruction results against Guillemot and Mustafa. The consists of two objects. These are is color coded and the initialization. So as an automatic framework for temporally coherent 4D reconstruction, quality, and joint segmentation and refinement was proposed. And to extend the work to single view video, introduced it. Thank you. Please visit our poster number 12 for